I think I can derive the input impedance, this equation, according to all the functions on the whiteboard. Okay? I want to try to do that. This is we will spend a little bit of time. So first of all, the Z in will be the total voltage at L and the total current at L. This is the definition of this one. And this one equals to V0 plus exponential minus positive J beta L plus V minus exponential minus J beta L. And this is the minus J beta L. Okay. And this one equals to I copy this one. I change I0 plus and I0 minus according to the definition of Z0. So this one will become Z0 plus over Z0 minus V0 minus over Z0. Okay? The same when we do a reflection coefficient, then we put the reflection coefficient this one will become gamma times 0 plus. And the same, this one become gamma times Z0 plus. Okay? Then I want to use this equation. I change the gamma to okay. Then copy this one. I want to use the Euler formula. Can anyone tell me how can we change these two terms? Use the Euler formula. Anyone? Raise your hand. 2 points. Euler exponential j beta L equals to, use the Euler. It's an easy question. Anyone? 2 points. Oh, I forgot to give you points when we take a break. Come here. Oops. Can all of you see? Can you see? Yeah. So if this is negative, you use negative. Okay? This is a Euler formula, exponential to the minus j beta z L equals to cosine beta L plus. This is B and beta actually different. You should use beta. Okay? So you can change this one. Cosine beta L plus j sine beta L Okay. Any questions? And for the rest, you don't have any, it's not very hard. What you need to do is just you multiply ZL plus Z0 to everywhere. And you divide every part by cosine beta L. Okay? And you can have the result as then you can obtain this one, but in this part I already put everything here. So I don't know if you can follow. I multiply these terms, and I can have a cosine and sine. For that one, for this one, I have everything here. I have the same thing. I can cancel out. So what can live in is 2 times ZL times cosine beta L plus 2 cos Z0 j sine beta L divided by 2z0 cosine beta L plus 2zl j sine beta L. There's nothing special. What you need to do is just put those numbers in. Okay? Okay? And after you do that, you can obtain the result from here. And because sine divided by cosine is tangent beta L, so you can take this result. This is the final equation we want to obtain. Okay? There are many definitions and the equations we use to derive the input impedance. At this point, your input impedance will be dependent on your characteristic impedance of your transmission line and the load you connected, and also beta L, the propagational constant of the transmission line and the length of the transmission line. Just use this equation. Okay? If you have a question, maybe you can see my website. I put the detailed derivation on the website as well. But I think the main point are these definitions and equations. Okay? Okay. If you think it is okay, I will ask you more questions. So far, we already know if there is a transmission line connect to a load, your input impedance will equals to your ZL JZL tangent beta L and ZL plus JZ0 tangent beta L. Okay? This is the result we already know. Let's see some special cases. What happened is when your load is connected to short. Anyone? Short. If this is this question, right? Okay. If I connect my transmission line, if my end of the transmission line is short, what happened? Anyone? Raise your hand. Which one equals to something if for this transmission line? ZL equals to anyone? Short. What is short? What is the load is short? ZL equals to, anyone raise your hand please? Right. Equals to 0, right? If this is short, not yet. So, if ZL is 0, Z in equals to
乘上 z 分之 j z 贝塔。
It depends on your answer. Give you 2 or 5 points. If I connect a transmission line to a short load, that's up to you. It's okay. If you didn't finish, you should finish after all. But I like to derive step by step. I don't want you to get lost. I don't want to just give you a result. Maybe you don't have any sense. Okay? I give you the result step by step and to understand if you know the result or not. Is that correct? Yeah. Yes. Why you always write down the beta like a B? Now those are different characters. B and the beta are different. B is Greek and the beta is yeah. So your beta is a little bit different. Yes. Okay. Wait. Now you already have. I give you 4 points already. Question. Z in is Z at L, right? Gamma equals to. This one is a harder question. Can you answer the question? If I connect to a load which is short, right? If this is a new load, what is the reflection coefficient at this point? Not at this point. At this point is easy, right? It's ZL minus ZL minus Z0 over ZL plus Z0, right? What is the reflection coefficient at this point? Why? No. Do you want to try more? This is 0. Yes, for this equation, this is the reflection coefficient at here. I'm asking about your reflection coefficient here. Do you remember? Because I already erased everything. Okay. If you don't want to try, not exactly. This is okay at here. But my question is here. No, they are different, right? You want to try? Come. Good. Nice. Correct, but this is not the question I want to ask, but you are a good student. That is correct as well. Okay, thank you. This is also one of the answer, but I'm asking the question before. Okay, my iPhone. This is also correct, but I'm asking about, okay, let's go back to, let's go, you are correct, but this is more, I want to ask the basic. I like to ask the basic questions. Do you remember what is the definition of this one? Anyone? 2 points definition. You think you answer the same question to get more points? Yes. Yes, because he remember, because he come here to answer question. The same. Yes. And L and the Z is different. Try to change. No, L. I want to use L. No. And wait. Oh yeah, it's correct. It's correct. Okay, good. Your E and the L looks the same. Okay, 2 more points. Okay, this is the question I asked. Okay, so what is this one? They are the same, right? This one equals to minus what? Right? Because of this one, this is your reflection coefficient at 0. Z and L are both 0. So this is a minus 1. So this one equals to minus 1 times exponential minus 2j eta L. Okay? What happened here? What is the answer of this is what? What is cell equal? Also, what? What are the different? The phase. This is 180 degree, and also the phase. But the magnitude are the same. So this one is like on the plane. One, you have different phase. You change the phase, but the result is the same. Okay? If you have a line connect to your load is short. Everywhere on this line, the magnitude is the same, but the phase is different. Phase is changing according to your location. Okay? If you use the VNA to try to measure your circuit, your S11, you measure S11 is 20 log your magnitude, your absolute value of reflection coefficient. You take a log and times 20. So, no matter what your load, your circuit is, if you connect a transmission line, they change only phase, but your S11 is the same because you take the absolute value. Okay? You will have more detail to. We will talk about more detail about the S11, S22, S21 in the chapter 4. They have more general definition. But here I give you some example about what happened. The magnitude is the same, but the phase is different. Okay? So for the short, okay, let's come back to my slide. Then you now have we have something. Okay, you can come back to my slide, but actually I did everything the same. I did everything the same. For this turn, if that is short, I connect that to a short. My input impedance becomes this one, and this, if this is 0, it is -1. So now you can put these two back to our definition. Then you can obtain your voltage and the current at this point will become these two equations. Okay, you just put a gamma as the -1, and I think gamma you would be fine, and then you put a Z0. Okay. So this, from the equation, you can see the voltage on the transmission line everywhere. This is the total voltage on every position of the transmission line and the current on that. Okay? And the total impedance, this equation, you can just only divide V over I will be the same. Okay, and get this one. This is the input impedance on a transmission line, and this transmission line is connected to a short, right? Connect to a short. See, you can see this impedance. What happened? When L equals to 0 at this point, the Z is 0 because this is short. Okay? But if from there's a tangent beta L, you can see that when the length of this transmission line, it is a quarter wave transmission line, is lambda over 4. Your impedance after this length, your short impedance will become an open because your impedance is going to the positive or negative value, infinite value, huge one. So your transmission line at the end looks like a open. This is short. This is a quarter wave transmission line. Look at that. This one looks like an open. Short become open. And after a quarter wave transmission line, it looks come back to a short. it is very weird only because this is a transmission line. You have a very, very high frequency voltage on the transmission line, okay? If there is no voltage, they are the same. The voltage will be the same. This only happens if that is a high frequency transmission line. So what is the quarter wave transmission line? You need to understand what is the wavelength. What happens if your frequency is very low? What happens? Speed of light, or we will say the phase velocity, will equals to your frequency times your wavelength, right? If your frequency is getting higher and higher, this is a constant. This one is getting small and smaller, right? Okay? If your frequency is 0, and this is the same, your wavelength is infinite. For the low frequency, very low frequency transmission line, your wavelength is infinite, which means lambda over 4 is also infinite. So every circuit you see, you can hold on your hand, they are super small. That's why you don't have these equations, because your wavelength is too big. Every physical length comparing to the huge wavelength is 0. So you don't see this one. Okay? Okay, so this is a special case if you connect to a short load. Similarly, okay, let's try to ask you more questions. What if I connect to open? Can anyone answer my question? If you answer all, then give you 5 points. Anyone? If you connect to open, anyone? 5 points. Don't. Come on. I will lead you to finish that. You just raise your hand. Raise your hand. Anyone? Open. Your Z0 is an open load. Can anyone want to try? Don't try. Too easy. Try. You didn't get points so far. Anyone? Anyone haven't get any point? Do you want to try? What happened? Okay, come here. Open. 5 points. It's not. Should be easy. Okay. So if you connect to an open, ZL equals to, yeah, let's go to infinite, right? So your input impedance will become, according to this equation, Zin equals to for 5 points, because you need to write it down, not only infinite. Yeah. What is Zin? Right? Okay. Copy. You just copy that. Copy that. I will help you. Copy that. Just write down. Zero is easy, but infinite is harder, right? But you need to think. Just one. Okay. Okay, wait. Okay. Let's look at only these two terms. If ZL is very big compared to Z0, what will this happen? This one will become, if this one is very huge, which part will disappear? Which one? Just take away, okay? Okay. And the ZL is larger than this one, which one will disappear? Yes. This term is also infinite, right? And this term is also infinite, but can you cancel something the same? Cancel the same thing. Cancel. Okay. Yes. So this one will equals true. This is an easy 5 point, man. Yes. Yes. Yeah, that's it. Okay. So if you have a transmission line connect to open, it is just like a broken line. It's an open load. Your impedance, okay, thank you. Your impedance will become ZO over J tangent beta L. Okay? And your reflection coefficient is also the same, but your reflection coefficient at 0 is one more question. What is this one? And this one will equal to so your reflection coefficient at this point will equals to yes, yeah, this is 1. Your reflection, okay, thank you. Reflection coefficient at this point is 1, but your reflection coefficient at the line is changing according to your length, but the magnitude is the same. Okay? No problem? Alright, let's see what happened to the open. You just change your J 1 over J to minus J here, and the 1 over tangent become cotangent beta L, and this is exactly the same as her answer. Okay. So if this is open here, and then your voltage become this one, and then your current will become that one at the position L. The voltage and the current, and you put your gamma 0, 1 here, and you divide everything, you can get a result. So, can you guys follow? Then you can get another picture, the figure of your voltage and the current and your impedance become from open to short to open to short. Okay, so open and short is changing. Open become short, short become open if you have a quarter wave transmission line. Okay? Okay. Somebody asked me, why, if I always, is there any method, any way you can measure only the positive wave? I want to is there any way? Because when I tell you from the telegrapher's equations, if your total voltage equals to V0 plus exponential J beta L plus Z0 minus exponential minus J beta L. This is positive forwarding voltage wave. This is reverse. This is reverse. Okay. Is there any way I can measure only this term? I don't want a reverse one. I want only him. Is that possible? What happens if I have only this one? Can anyone tell me? How? Yeah. Yeah. Because you were, okay, 2 points. Okay. V0 minus equals to gamma times V0 plus, right? If gamma equals to 0, you don't have this term, right? Okay, more question, more point, okay? How to make gamma equal 0? How to make gamma equal to 0? Two more points. Yeah. How? Tell me. How? Wait, hold him. Not hard, right? So I said 2 more points. How? What happened if I want gamma equals to 0 and I don't have this reverse wave? I keep only forwarding wave, positive wave. How? ZL equals Z0. Why? Because equals to ZL minus Z0, ZL plus Z0. So, if your characteristic impedance equals to your load impedance, you don't have a reflection. Okay, let's take a break and you guys